In this video, we're going to talk about solving systems of equations that in non-linear variables. So the first thing we want to make sure we understand is that when we add two variables together, this is going all the way back to basic algebra, that if I wanted to do any kind of elimination, that if I wanted to eliminate y squared and y, I can never add y squared plus a negative y and get one complete variable. We can't combine things that aren't like terms. So elimination at this point is really not available to us. So what we have to do is we now have to use the idea of substitution. So what I'm going to do, that popped up a little bit. So what I'm going to do then is I'm going to take this equation here and substitute it in here. So what I can do is I can solve for one of the variables. I'm deciding to solve for x. So this is the same as x is equal to 1 y plus 1. Now solving this equation for one variable, I can plug it into that equation. So I have y plus 1 squared plus y squared is equal to 25. And that becomes algebra. Please remember that I have to expand my binomial. Don't just say it's y squared plus 1 and work this all out. So see if you can get it worked out and solve. So first of all, I expanded the binomial, got everything together. Now what I'm going to do is I'm going to combine like terms, and this is a quadratic, so I have to either factor it or complete the square or use the quadratic formula. So when I used one of my techniques, I found that y is equal to -4 and y is equal to 3, but I still need the x values for each one. So I'm using the old equation of x minus y is equal to 1. So the first thing I'm going to do is x minus my first y. That should have been 1 there. And then so x is equal to -3. So my first point is -3 comma -4. Then I'm going to do it again for the next one. So we're going to have more than one point. When we did linear equations, we had only one intersection point, but these are nonlinear. I've got a circle intersecting with a line, so we're going to have more than one. So I've got x minus 3 is equal to 1. So my point is x is equal to 4 in this case. So we've got the point -3, -4, and I also have the point 4, comma 3. Looking at this next problem, I can again solve for x. So I have x is equal to -3 minus y. And then what I'm going to be doing is I'm going to be putting that value in for x there. So pause the video, put that in and expand the binomial, and then combine like terms. So here's the work. Working it down, I get my y values are 3 and -1. That means I'm going to have 2 points where y is 3 and where y is 1. So working that down, I'm going to put this into my simpler equation, which is x plus y is equal to -3. So in this case, x is equal to -6. So I've got 1 point of intersection. Then I'm going to have x plus my y is equal to -3. So x is equal to -2. So that's my other point of intersection. So I'm going to have 2 points of intersection, again, between this value here and this line here. The other thing I want to point out is if I have where two equations where we can eliminate, like again, add x squared plus x squared, then we most certainly can do the substitution method. So this can go back to what we do in linear equations. So let's start here by looking at what I can multiply both of these equations by. And I'm going to try to eliminate x. It seems to be a habit. So let's start there by eliminating, find what coefficients and what I need to multiply by to get these x's to cancel out. So I decided to eliminate the coefficient of x squared by multiplying the top one by 2 and the bottom one by -3. So when I add those down, I get 17 y squared minus 17 is equal to 0. And this one I can simply solve out this way. So y squared is equal to 1. So I have y is equal to 1 and y is equal to negative 1. So I have two values of y again. So putting that back in, I have to put it into one of the other equations. I decided to put it into the first equation. So 3x squared plus 4 times 1 squared minus 16 is equal to 0. And this one I got x is equal to 2, x squared is equal to 4. So x is equal to 2 or negative 2. When I solve it, actually it works out the same way because squaring negative 1 and squaring 1, I will end up with the same thing. So I have 3x squared plus 4 negative 1 squared is equal to negative, minus 16 is equal to 0. So that means I have x squared is equal to 4. So x is equal to 2 and negative 2. So what I actually have now is 4 points. I have 1 when x is 2. I have 1 when x is negative 2. So that's 2 points. But I also have negative 1 when x is 2, and I have negative 2 and negative 1. So I have 4 points in this equation. So when we are doing nonlinear systems of equations, we can end up with multiple intersection points. So keep that in mind as you solve, whether you do elimination or you do substitution.